Hello, and welcome to lesson 2 in your purple packet. This time we are going to be transforming the linear parent function with vertical and horizontal shifts. So before we get to that, we're going to practice graphing because you're going to be graphing in this lesson. So up here at the top, we have this section that we're going to do first. So they give us slope-intercept form, which is f of x equals mx plus b, or y equals mx plus b. M stands for slope, b stands for y-intercept. Hopefully you remember that. I am going to identify the slope and y-intercept from this function, and then you are going to explain how to use those two pieces of information in 3 steps to graph it on the graph. So I'll help you with the slope and y-intercept. The slope is always in front of x because m is in front of x and m stands for slope. So this is my slope. Well, if I look in my function, in front of x, I have the number 3. So my slope, or m, is 3. Now, b is usually at the end, not always, but it is always by itself. It never has a variable next to it. Well, if I look at my function, the number that is by itself is 7. So that is my y-intercept. So I want you to pause the video for a few minutes and see if you can come up with the 3 steps of how you take these 2 pieces of information to graph this function on the graph here. So pause the video, pause, and see if you can come up with the 3 steps. If you can't after a few minutes, then hit play and I will tell you how to do it. So, hopefully you paused it and you wrote something down, and hopefully you're writing in a pencil so that if you didn't do this correctly, you can erase it and write the correct steps. Anytime that you have an equation or a function that is in slope-intercept form, the first thing that you are going to do to help you graph that on a graph is to plot the y-intercept. The y-intercept always goes on the y-axis. So you look at your y-axis, you start at the origin. My y-intercept is 7, so I'm going to move up 7 places or 7 spaces and put my first point there. 1, 2, 3, 4, 5, 6, 7. So that's step 1. I took this number and I put it on the y-axis because it is my y-intercept. Step 2 is to use your slope. How do we use slope on a graph? Hopefully you said or you think rise over run. So you use the slope as rise over run. To add more points. I would say at least 2 or 3 more points. The more points you put on your graph, the better your line is going to look. So, but you may be thinking, well, Mrs. Flores, this slope is not a fraction, and rise over run is a fraction. And if you think that, you're correct. Well, I ask you, how do you turn a whole number into a fraction? Anytime that you want to turn any whole number into a fraction, you put it over 1. So all I have to do is put 3 over 1. And now I have rise and run. 3 is positive, so that tells me I'm going to go up 3. 1 is positive, so I'm going to run to the right. So I'm going to go up 3, right 1 from the y-intercept because that's the only point that I have on my graph so far. So up 3 over 1. And I'm going to do it again. Up 3 over 1. Now, I can't go up 3 and over 1 anymore because I only have 2 spaces. But if I go back to my y-intercept, I can add more points this way, but I have to do the opposite of this. So instead of going up and right, the opposite of up is down, and the opposite of right is left. So I'm going to go down 3 and right 1. Down 3, right 1. Now I've added 4 extra points aside from my y-intercept, so I think that's good. the last step, because some of you forget to do this. The last step is to actually connect the points to create a line. If I do not connect these points, then this is a discrete graph. It is not a line. It is points that are in a line, but it is not a line. So if you have your ID, you can use that. You really just need a straight edge to connect your points. Now, that was just a quick review because we're going to be graphing later. So now we're getting to the real lesson. So we're going to be transforming the linear parent function with vertical and horizontal shifts. So this is the graph of the linear parent function. And in the last lesson, we learned that the linear parent function is y equals x, right? Well, this is the same thing. F of x equals x is the same thing as y equals x. We're going to use this table to graph g of x, which is f of x minus 4. So we're taking the parent function, but we're doing something to it. So if I look in here, it tells me to do minus 4. Well, what am I subtracting 4 from? X. So I am going to take the x values of the parent function, and those are the x values that are in here that I'm going to use in this middle column. So all of my x values are coming from the parent function. Oh, and we missed these. In order for this to be the parent function, the missing values are 4 and 5. So now to each of these x values, I am going to subtract 4. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4 is negative 2. 3 minus 4 is negative 1. 4 minus 4 is 0. And 5 minus 4 is 1. These are now my new y values. This is my output. So now in this last column, I'm going to write my new ordered pairs. The x values aren't changing. So the x values are independent. They stay the same. So my new ordered pair here is 0, negative 4. Because this is my new y value. This is my new y value. This is my new y value. So the x values are staying the same. So this is 1, negative 3. This is 2, negative 2. This is 3, negative 1. 4, 0. And 5, 1. Well, now that I have these ordered pairs, I'm going to take these ordered pairs and I'm going to graph them. I'm graphing these. And then we're going to see how that affected or changed this linear parent function graph. So I start at the origin. I'm not moving sideways. I'm just going to go down 4. So 1, 2, 3, 4. Now I'm here. This means I go right 1, down 3. So back at the origin, right 1, down 3. This tells me right 2 because it's positive and x moves sideways, and down 2 because my y is negative. So back to the origin, right 2, down 2. This is right 3, down 1. So back to the origin, right 3, down 1. Right 4, down none. So all I do is move over 4. And this is right 5, up 1. Because now the y is positive. So there are my points. Again, this is not a line until I actually connect them. Which is why we had you do that in the example before we started the real lesson. So, connect the points. There's my new line. Okay, so now I'm going to do the same process with my other table. Well, this time I'm taking the linear parent function and I'm going to use the table to graph f of x plus 4. So don't do minus 4 because this time this tells us to do plus 4. Again, I'm taking the x values from the parent function They're here. That's what I'm using here. So 0, 1, 2, 3, 4, 5. And if you really wanted to, you could go ahead and put them here because the x values are not changing. We're only getting a new y value. So I can't fill those in yet because we actually haven't done the math, but then when I do it, I can just fill the second part in. Well, this time this tells me plus 4. So 0 plus 4 is 4. So my first ordered pair is 0, 4. 1 plus 4 is 5. So my next ordered pair is 1, 5. 2 plus 4 is 6. So my ordered pair is 2, 6. 3 plus 4 is 7. So 3, 7. 4 plus 4 is 8. So 4, 8. 5 plus 4 is 9. So 5, 9. So once I have all of those ordered pairs, now I graph them. So remember, this number always tells you what direction you move sideways. That's the x value. If they're all positive, that means we're only moving right. And then the y value tells you how many spaces you move up or down. They're all positive, so they're all going to be right and up. So the first one means I don't move any spaces sideways because it's 0. I'm only going to move up 4. That's my first point. Then I go 1, 5. So right 1, up 5. Then back to the origin, right 2, up 6. You can kind of see the pattern. So you may not need to actually go back to the origin and do it because the slope is 1. So over 3, up 7. Back to the origin, over 4, up 8. And then the last one, over 5, up 9. Now again, remember, it's not a line until you actually connect it. So I'm going to connect these these points to create a line. And now I have two different graphs because I did two different things in my table. So down here it says, how does the sign inside the parentheses affect the horizontal movement of the line? So when the sign is inside the parentheses, it is going to affect the horizontal movement of the line. So I'm going to use my paper clip to try to see if we can figure out how it moved. Horizontal is sideways. So it means I'm either moving left or right. So if this is my parent function and it ended up here, that means I took this and I moved it to the right. So I'm going to draw an arrow that shows that I moved this line over to the right. Now, for the second example, we had plus inside the parentheses, but this time it caused us to move in the opposite direction, which is left. Now, I know this seems kind of backwards because normally if you're moving sideways, a minus or a negative would mean you move backwards or left, but it actually is the opposite, so you move right. So when you have minus inside the parentheses, like we did in the first example, right? So when we have f of x minus a number inside the parentheses, that is going to equal a shift. What direction did this move? Right. Okay. Well, now when we have the opposite, when we have plus a number inside the parentheses, that is going to cause a shift left. If you think about what we did was we took the x-intercept, because it's inside the parentheses next to the x, and we moved it over. In this case, we moved the x-intercept to the left 4 spaces. In this example, we took the x-intercept and moved it over to the right 4 spaces. So when you have a sign inside the parentheses, it is going to cause you to move or transform the x-intercept. And it's easier to remember because that number that you're adding or subtracting is inside the parentheses next to the x. Okay, so now we have a couple more examples. Now, these may look exactly like what we did last time, but these are different. Because if you look carefully, this minus 4 is not inside the parentheses. It's on the outside. And this plus 4 is also on the outside of the parentheses. So, I'm not going to do the whole table to save us a little bit of time. But we'll go ahead and fill these in, right? In order to have the parent function, the x and y values must match. Well, this time I'm taking f of x and I'm subtracting 4 from it. So instead of taking the x values from the parent function, I'm taking the y values. So this time we're moving the y. Last time we were moving the x. So 0, 1, 2, let's do 4 points. So we'll do 0, 1, 2, and 3. Well, what am I going to do to each of these y values? I am going to subtract 4. Well, 0 minus 4 is negative 4. So my ordered pair is 0, negative 4. 1 minus 4 is negative 3. So my ordered pair is 1, negative 3. 2 minus 4 is negative 2. So I have 2, negative 2. 3 minus 4 is negative 1. So I have 3, negative 1. You can fill in the other points if you'd like, but I'm trying to save us a little bit of time. So now I'm going to graph these. 0, negative 4. So I don't move sideways. I just go down 4 spaces. Back to the origin. Right 1, down 3. Back to the origin. Right 2, down 2. Back to the origin. Right 3, down 1. I'm going to go ahead and connect these to create my actual line. Don't forget to do that part. If you don't, then it's just a discrete graph. It's just a bunch of dots if you don't connect them. Okay? So now for the next example, I'm going to add 4. I'm still taking the y values. 0, 1, 2, 3. But this time I'm adding 4. Well, 0 plus 4 is 4, so 0, 4. 1 plus 4 is 5, so 1, 5. 2 plus 4 is 6, so 2, 6. 3 plus 4 is 7, so 3, 7. So now I'm going to graph those. If you want to fill these out, go for it. Your teacher will not be upset if you do extra points than what I did. So 0, up 4. 1, up 5. 2, up 6. 3, up 7. All right. So now, this time it says, how does the sign on the outside of the parentheses affect the vertical movement? Well, this time it's vertical or up and down because this time we were doing that to the y values. So remember, f of x is the same thing as y. So we took the y value and we shifted that. So these look exactly like the other graphs we did, but the equations were different. So these look the same, but the equations are different. This one had minus 4 on the inside. This one had minus 4 on the outside. So even though the graphs look the same, it is a different kind of shift. So if it moved vertically, right, vertical is up or down. So if I'm here and I end here, I moved down. So I'm going to draw an arrow that shows me moving down. Well, if I started here and ended here, I shifted up. So how does the sign on the outside affect the vertical movement? Well, if I have f of x minus a number on the outside of the parentheses, it is going to equal a shift down. If I have f of x plus a number That is a shift up. Well, if we are moving it up and down, we are transforming or moving the y-intercept. So I took this and I moved the y-intercept up 4 spaces. I took this y-intercept and I moved it down 4 spaces. So we move or transform the y-intercept when we have that plus or minus on the outside of the parentheses. All right, a couple more quick examples because this is what you're going to need to know how to do to complete your practice. So we can do the same work we did up here without doing all of this extra work in the tables. But we have to do it this way in order for this to make sense. So if you follow these steps, you can still graph these functions, which are causing your parent function to shift in a specific direction, without having to do all that work inside the table. So first, you need to identify what kind of shift is happening. Okay, well, I have plus 5 inside my parentheses. Well, the notes here tell me that when I have plus a number on the inside of the parentheses, this is a shift left. So this is a shift left. So then it says plot the first point from the shift. So if I'm moving sideways, I am moving or transforming the x-intercept. So I'm going to take my x-intercept and I'm going to shift it left that many spaces. 5. 1, 2, 3, 4, 5. Right there. So that is step 1 and 2. Then it says, what is the slope? Well, if I look at my function, the slope is always in front of x. We did that in the review example at the very beginning. Well, there's no number in front of x. So when there is no number in front of x, you imagine an imaginary 1. So if I have 1 over 1, that is my slope. Once I identify the slope, I use the slope to plot additional points. That's why we did that example at the beginning. So my slope is 1 over 1. That means up 1, right 1. So from the x-intercept, because that's the only point we have so far, I go up 1, right 1. 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 And then the last step is to connect the points to create the line. Do not forget to connect them. Okay. Now, I need to draw an arrow to show what kind of shift it was. Well, if this was a shift left, then I just draw an arrow pointing from the parent function over left to my new function because that was a shift left. Well, this next example, I have plus 5 on the outside, and that's the ones we just did up here. So if I plus a number on the outside, that is going to be a shift up. Okay, so I'm going to take my y-intercept and I'm going to shift it up 5 spaces. My slope is still 1 because in front of x, I have nothing. So when there's nothing in front of x, there's an imaginary 1. So my slope is 1. To make it a fraction, I put it over 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. Connect the points. And I need to draw an arrow that shows it shifting up. Now, these two graphs look exactly alike. If I took away the arrows, you wouldn't know what direction I moved it. The graphs look exactly alike, but they are two different shifts. And it all depends on what the equation looks like. When I have the number inside the parentheses, the plus or minus are going to cause me to move my parent function sideways. When I have it outside of the parentheses, it's going to cause it to move up or down. So even though the graphs look the same, they are two different shifts. One is left and one is up. Now, the last example I am not going to do for you. I want you to do it. following these steps, but I will help you by identifying the type of shift. So we just said when we have minus a number inside the parentheses, it is left or right. The left or right ones are the tricky ones because those are the opposite. So when I have minus, it is actually a shift right. So I take my x-intercept and I move it to the right 3 spaces. That's all I'm doing for you there. The last one is minus 3 on the outside of the parentheses. So that is going to be a shift. What do you think? If you said down, you are correct. Y-intercept this time because we're moving on the y-axis, and I'm going to move it down 3 spaces. From there, you should start at step 3 and finish it off. Do not forget to draw your arrows because the graphs are going to look the same, but one is a shift right and the other one is a shift down. On your practice, you must circle what kind of transformation it was and graph it. So, if not, your teacher is not going to give you credit. I know I'm not. +6 means a shift left. So I move my y-intercept to the left 6 spaces. My slope is still 1. I connect my points. And it says right here, draw arrows. I need to draw an arrow pointing in the direction that I circled. If you do not do your practice like this, you will not get full credit. Go practice.